All right. Let's begin. Did you try solving the problems? Anyone? Did any of you try solving the problems? All right. So looks like no one attempted. Let's go about doing it. So let's do it as per the schedule. So we did sorting, we did filtering, right? I mean the initial list. So when we did sorting, we did that two ways. One is by attribute, and the other one is by some comparison logic. So the comparison logic is being passed as a comparator function, right? This is not new, right? If you look at it, whatever we did is not new. We have been doing this in object-oriented languages as well, except that in OO languages, the way by which we accomplish this is a little complicated affair. How so? If you remember in Java, right, the way we would do it is, or at least in .NET, you will have an eye comparer interface, and then you need to write a class product comparer by cost. Now the eye comparer interface will have a method called compare method that will take two items, item 1 comma item 2, and returns what? A numerical value, returns a integer value. So you will create a product comparer by cost, implementing the eye comparer, right? Implementing the eye comparer, and thereby implementing the method, compare method for this particular class, and then we will have to create a new object. So where product comparer by cost is equal to new product comparer by cost, right? New product comparer by cost, and then you will have to say sort of comparer by cost, right? So all these things you have to do because you have to satisfy the compiler, because it is a strongly typed language, and the compiler has to know what kind of object you are passing. And why should I pass object? Because that is the least possible way by which you can pack state and behavior together before you pass it over to someone else, right? So in order to create an object, you need a class, and in order to tell the compiler that the object can be one of many different types, you have to have a common interface to do that. So all these things you need to do only to pass one comparer function implementation, right? All these things you need to do only to pass one comparer implementation, right? Now in JavaScript, right, you are achieving the same thing, except that you don't need a comparer, you don't need a class, you don't need an object. All you do is just pass one function implementation and directly, and you are good to go. Right? Now we are able to pass a function as an argument. You see here we have product comparer by value, and we are able to pass this function as an argument to the sort function, and thereby we are able to inject the comparison logic. So this is a lot more simple, right? Functions being able to be passed as arguments to other functions, right? What are these functions called as? These functions are called as higher order functions, right? These functions are what you call as higher order functions. So what are higher order functions? Functions that can take other functions as arguments, or functions that can return a function as a return value, right? What is the use case for a function to be returned as a return value? Anyone? What is one common scenario why you would want a function to be returned as a return value? What is one common scenario why you would want a function to be returned as a return value? Guys, we discussed this in length. no, no. For creating closures. For creating closures, right? For creating closures. So we tried this with the memoize example, right? We returned an inner function as a return value, right? Now functional programming is all about how you can exploit higher order functions to solve problems. Okay, now what is this? There is a specific pattern for this. There is a specific pattern for what we have done here. Can anyone tell me what pattern is that? Strategy pattern, right? Strategy pattern. So you have one main algorithm, and one part of the algorithm can be substituted by one or more choices, right? One strategy or another strategy. Here you have you have what? You have comparison strategy. You have several comparison strategies, and depending on your need, you pass one comparison strategy in place of the other, right? In place of the other. So that's where the strategy pattern comes into picture. In static languages, the implementation strategy of the strategy pattern can be a little complex. You need to have interfaces, classes, etc. Whereas in functional languages, it is as simple as passing a function as an argument to another function, right? So good. So this is pretty much about your sort. Now sort is done. What is the next one? The next one is filter. The next one is filter. So let us write that. Display. Okay, not here. Right. So this is all sort. Let me close this. Let us write filter. Display of filter. Filter, comma, a function. Right. Now let us write one specific implementation of filter, and then later we will see how you can generalize it. Let us write one specific implementation of filter, and then later we will see how we can generalize it. What implementation that we want to have? Say for example, I want to find all costly products. Right? I want to find all costly products. So how do you classify costly products? Any product that has the cost greater than 50 is considered to be a costly product, right? So how do we do this? Let us write a function that does that. So function filter costly product. Filter costly product. All we will do is where result is equal to an empty array, and for where I equal to 0, I less than products dot len I plus plus. If products of I dot cost is greater than 50, then result dot push the products of I, right? And finally, once the loop is done, return the result. Now I'll say where costly products is equal to filter costly products, right? The name can be a little misleading, costly products, because it is returning an array, right? So costly products, and we will say console dot table of costly products, right? Console dot table costly products. Save this, go to the browser. Okay, so I need to open it in the browser. And open the console, right? Now reload this. There it is. Now these are all the costly products. You see all these products that are greater than 50, right? All these products that are greater than 50. Now is there a way by which we can generalize this so that we should be able to filter anything we want based on any condition? Let us write just one more filter and then see if we can find out how we can make something generic, right? The way I always like to create abstraction is write specific implementation and then see, keep whatever is common together, and what will be varying, whatever will be varying, move out, right? So that you can create a generic version of the particular functionality, right? Keep what is common and move out what is varying. There is a name to this. It is called commonality variability, right? So identify whatever is common, keep them together, and identify whatever is varying, push them out, right? Commonality variability. Now, this is a general concept, and the concept can be applied in different forms in different types of languages. Now, here, let us try to write one more functionality. What is it? All products that belong to category 1. Right? All products that belong to category 1. So, function all filter category 1 products. Right? Filter category 1 products. Now, let us say where all category 1 products. Okay, sorry. Where result is equal to an empty array. For where I equal to 0, I less than products dot length I plus plus, take one product at a time. So if products of I dot category is equal to 1, then result dot push the products of I, and finally return the result. Now here I will say where all category 1 products is equal to filter category 1 products. Now console dot table all category 1 products. Save this, go back, reload this. You'll find that these are all costly products, 90, 70, 80, 60, 80, whereas these are all category 1 products. Right? These are all your category 1 products. Very good. So, but then we have written two different functions, one for costly products and one for category 1 products. What is common? You will find that between these two, you will find the array declaration is the same, the for loop is the same, right? And the result dot push is the same, the return result is the same. What is changing is the logic by which you check if a product satisfies your criteria or not. Yeah, now is it audible? Now is it audible? Oh, okay. There was a power failure, so I lost the internet connection. Thank you, guys. Okay. So now if you look at here, everything is the same. Everything is the same except one thing. What is it? Except your condition. Right? Except your condition. Now, how can I generalize this so that I don't have to rewrite the same function again and again and again? How can I generalize this? What I can do, see, let's assume that this function is me and you are using the function, right? So what I will do is I will take one product at a time, give it to you. You decide whether the product satisfies your criteria or not, and then tell me yes or no. So that depending on that, I will simply decide whether it has to be added to the result collection or not. Right? So a very generic version of this is keep everything together, move out what is varying, which is what? The criteria, right? So if I have to externalize this, the only way by which I can, or one of the simplest way by which I can externalize this is by writing a function. right? So you give me a function. To your function, I will give you one product at a time. You return me a true or false, and based on that, I will decide whether that particular product has to go into the result array or not. So a generic version of this will go something like this. Look at this. Let me take a copy of this. Let me take a copy of this, and I'll write it as plain simple filter. Take a list, right? And we are making it a little generic. So take a list. Okay, good. But then I am not going to use a cost, right? I am not going to do the comparison myself. I am expecting you to pass a criteria function. Okay, so criteria function, and if I will, if I invoke the criteria function, right? If I invoke the criteria function and pass you one item at a time, right? And you tell me whether it satisfies your criteria. So you can say is equal to true. So if while invoking the criteria function with one object and you return me true, then I will assume that the product satisfies your given criteria, and I will add it to the result and give you after you call after the iteration is completed. Now let us see how we can use it. So this, let me comment it out. So this is more specific implementation. We are not interested in this. Now how will I use it? Watch this. So I'll say display of all costly products. What is costly product? Cost is greater than 50, comma, a function where I'll simply say where costly product criteria is equal to a function that takes one product at a time and returns if the product.cost is greater than 50. Now where all costly products is equal to filter products comma costly product criteria. I am just passing the reference of this function. Now what will happen? The filter function will take one product at a time, iterate through this, call this function passing one product at a time, and your function has to return true or false. If it returns true, then you are going to add it to the result and return it. Now this is just for readability, but you don't need the equal to true, because you are writing that in a if condition, so it will automatically evaluate it to true or false. Now save this, go back here, reload this. You'll find that all costly products are not there. Why? Because I haven't done a console.table. So console.table all costly products. Save this, go back here, reload this. You see, all the costly products are listed here. So now all I have to write is, I don't have to write new filter function again and again and again. I only have to write my specific criteria. That's all. Now let us also do the category 1. So display all category 1 products. Right? All category 1 products. The function, and we'll say where category 1 product criteria is equal to a function that takes one product at a time and returns if the product dot category is equal to 1. Now where all category 1 products is equal to filter of products comma category 1 product criteria. Now console dot table of all category 1 products. Save this, go back, right? Save this and reload it. You'll find that, see, it shows all category 1 products. Now all you have to do is, for different filter, you just need to write different criteria function. So what is a criteria function? A criteria function is a function that takes one argument and returns a Boolean value, right? Now for better understanding, I named it as criteria function, right? But in functional languages, this function is called as a predicate, right? This is called as a predicate. So a predicate is a function that takes one argument and returns a Boolean value, right? So here, this is a predicate, this is another predicate. So a filter will take a list of products and a predicate, and the filter will take one item from the list and then call the predicate, and if the predicate returns true, it will add it to the result, otherwise it will not add it, it will simply return the result. Right? So this is about filtering. Now, how will I find all affordable products? How will I find all affordable products? Let us write that. So display all affordable products. So what are all affordable products? I can say affordable products are cost less than or equal to 50. Right? Cost less than or equal to 50. Now write a simple function. And here let us say where affordable product criteria is equal to a function that takes one product at a time, and you simply say return if the cost is less than or equal to 50, right? And then we'll say all affordable products is equal to filter of products comma affordable product criteria console.table affordable all affordable products, right? All affordable products. Now save this, go back here, reload this. Now you see these are all costly products 90, 70, 60, 80, and these are all affordable products 30 and 40. 30 and 40. Now the main question is there any other way by which you can explain what an affordable product is? Is there any other way by which you can explain what an affordable product is? Other than costly, exactly, right? So I can not a costly product, fantastic, right? So if it is not a costly product, it is an affordable product. If it is not a costly product, it is an affordable product. So instead of this writing this affordable product criteria, right? What I could have done, I mean, instead of writing this condition, what I could have done, I could have simply said, let us make the costly product criteria available to us. So let me take this, extract it, put it at the top, so that the scope allows us to access it in another function. Okay. Now, similarly, what is where affordable product criteria? The affordable product criteria is instead of explicitly defining the criteria. Right? Instead of explicitly defining the criteria, I can use the criteria that already exists. How? I can say return, call the costly product criteria of product, but not as it is. But not as it is. The not of costly product criteria is affordable product criteria. Right? So I don't have to define the 50 again here. So tomorrow, when the baseline changes, so tomorrow due to some reasons, the organization decides that 50 is not the baseline for costly product, 40 is the baseline for costly product. Then all I have to do is just make changes here instead of making changes into two criteria functions. Right? Change becomes easy because I am reusing the existing logic. I am reusing the logic that is already here. Now let us check if this works. Of course, if this works perfectly fine. Right? This works perfectly fine. Now let me make this description. It is not cost less than or equal to. It is not a costly product. An affordable product is not a costly product. That's all. Now, okay, very good. Now, can I do the same thing with non-category 1 products? Of course, you can do that. So let me take a copy of, take the criteria function, drop it here so that I can use it. Now, this is all category 1 products, and where non-category 1 product criteria is equal to a function that takes a product and okay, let me write it here, right? So let me write it here. A function that takes a non-category 1 product criteria equal to return not of category 1 product criteria passing the object. Now let me take this, paste it here and say non-category 1 products. Non-category 1 products. This is non-category 1 products. And this is the non-category 1 product criteria. Save this, go back, reload this. Now you see, so all category 1 products, that is, this is non-category 1 products. Here it is all costly products, this is all affordable products. But if you look at here, right, I am rewriting these criteria from the scratch. The affordable product criteria is not a costly product criteria. A non-category 1 product criteria is not a category 1 product criteria, right? I am rewriting this logic again and again and again. If you look at this, right, between these two, right, let me take this, let me take it and put it here, just for comparison. If you take only these two functions, right, if you take only these two functions, this remain the same, function product, this remain the same, the return not remain the same, but what is changing? Only the criteria that you want to check against changes. So this is replaced with this, right? Now, is there a way by which we can further generalize this? Is there a way by which we can further generalize this? Yes. How? Pay attention and let me know if you don't follow this. Let me create a simple function called a negate. Right? Let me create a simple function called a negate. And the negate will take a criteria function as an argument. The negate will take a criteria function as an argument. And then I will take a copy of this function, paste it here, right? Now this is going to be returned. I am going to return a new function that will internally use the criteria function here. Are you with me? Right? Now I don't need to explicitly write these function definitions. Instead, what I will do, I will write only one criteria, but I will say where affordable product criteria is equal to negate of costly product criteria. Similarly, where non-category 1 product criteria is equal to negate of category 1 product criteria. Now this negate function will give me the appropriate criteria function negating the original criteria function. Now will this work? This will work perfectly fine as well. You see how simply we are able to compose one function in another function and still get a common functionality done. Beautiful, isn't it? Right? And this is possible only because JavaScript is a loosely typed functional language. Otherwise, this is not so easy. And I remember creating. Okay, what is the design pattern? What is the overall design pattern? This criteria, predicate, etc. What is this? Specification pattern. Right? Specification pattern. Usually the specification pattern will have a iSpecification interface that has a method called isSatisfied by and you will pass an object as an argument to the is satisfied by, that will return a true or false. It's a little roundabout way of doing this. Whereas in JavaScript, it is as simple as passing a function around, right? It is as simple as passing a function around. It works perfectly fine. But here is one more challenge. What is the challenge? The challenge is this negate function will work on a criteria function that take only one item as an argument. What if I want to negate a criteria function that takes more than one argument? What if I want to create a negate function? I want to use the negate function on a criteria function that takes more than one arguments. Very simple. You already have the arguments object, right? So remove this and say criteria function dot apply, right? Apply this comma arguments. So the arguments of this function becomes the arguments of the criteria function. Invoke it, and whatever comes, you simply negate it and return this. That's all. Now go back, reload this. Everything works. Still works just fine. Everything still works just fine. Okay. Now here is the question. What if I want all category 1 costly products? What if I want all category 1 costly products? Right? I want two conditions to be combined using an AND. Very simple. You can simply say a function AND criteria takes two criteria functions. So criteria function 1 comma criteria function 2, right? And what it will do? Return a function that does return criteria function 1 dot apply of this comma arguments and criteria function 2 dot apply this comma arguments. Right? Now this is your AND criteria. Now let us write this. Display all category 1 costly products. Category 1 costly products. What is it? Cost is greater than or equal to 50 and category is equal to 1. Right? Category is equal to 1. Now a function, and I'll simply say where all category 1 costly product criteria is equal to a function that takes category 1 is a function is nothing but AND criteria of two things. What are they? Category 1 product criteria and costly product criteria. That's all. Right? Now where all category 1 costly products is equal to filter of products comma this category 1 costly product criteria. Pass this. Now console.table of all category 1 costly products. Save this, go back, reload this. Now you will find that, see, by earlier costly products were 4 products, of which one of them is what? Category 2, right? Now when you perform an AND condition on both of them, costly product and as well as category 1, all you get is only category 1 products. All you get is only category 1 products, right? Now if you want to write an OR condition, you can very well write a OR condition. So it doesn't take much. So how do you write an OR condition? Very simple. So function OR criteria is criteria function 1 comma criteria function 2. Basically predicate 1 and predicate 2, and what we are doing here, we will simply return this by replacing the AND with an OR. right? By replacing an and with an or. Now this I will say all category 1 are costly products, right? So now all category 1 are are costly product criteria is an R criteria of these two. Now pass this here and say this is all category 1 are costly products. Copy this, paste it, save this. Now you'll find that it gives you these four. Why? The first three are category 1 and the last one is the costly product. Right? The last one is costly product. See how we are able to compose different functions into what we want to do. Make sense? Right? We did negate, we wrote and criteria, we wrote or criteria, and we were able to combine all of them together. Guys, any questions? Are we good? Hello? Do you want to take a few minutes, go through it? Shall I check in the code? Will that help? Okay. So I'm checking in the code. Code is checked in. Shall we? Okay, good. Now, okay. So this is about filtering. Now let us write the next one. Let us solve the next one, which is what? All. All is a lot more simple, right? All will take a predicate. So most like filter, but it will work like in a slightly different way. So display of all is a function. A function, and here you write the all function. All, take a list and a predicate. Okay, take a list and a predicate. As I said, what is the functionality of all? All will check whether all the items in the given list satisfy a predicate, right? Whether all the items in the given list satisfy a predicate. So we are writing the function, and it will be very simple. We take a predicate. Predicate is what? A criteria function. As I told you earlier, it is just a plain simple criteria function. So now here, let us take for example for, where I equal to 0, I less than list dot length I plus plus, and if not predicate of list of I. Okay, if one of the item does not satisfy the criteria, if one of the item does not satisfy the criteria, you simply return false. You say no, not all products satisfy the criteria. Otherwise, once the loop is completed, you simply return true. Right? Now, where costly product predicate is equal to a function that take one product at a time and say return if the product dot cost is greater than 50. Right? Now we'll say where are all products costly is equal to all of products comma costly product predicate. Now console dot log are all the products costly, are all the products costly, comma are all products costly, are all products costly. Say this, go back here, reload this. You see that now? It says are all products costly? No, right? There are affordable products. So it gives you, they all works perfectly fine. Now similarly, you can also do any. Any is a lot more simple. Is there at least one product that satisfies the criteria? Right? At least one. Right? All is all of them. Any is at least one. So the any implementation is more or less similar to all with the criteria reversed. How is it? If at least one item, if predicate of list of 5, then return true. If at least one item satisfies the criteria, return true. Otherwise, if the complete loop is completed, say return false. Now here we have the costly product criteria. Now I'll say any costly products or any of them, any of the products costly, right? Or any of the products costly. So I'll say any, right? Or any of the products costly. Now save this, go back, reload this. Now it says yes, true, because there is at least one product that is costly, right? There is at least one product that is costly. So this is how you write the implementation of any and all. Okay. Now count by. Count by is once again very similar implementation, right? So you have to count the number of items based on the criteria. So here we will say count by, and count by the list predicate, and I will simply say where count where result equal to is equal to 0, and if it is satisfying the criteria plus plus result, and finally return the result. Finally return the result. Now costly product predicate. Now number of costly products. Number of costly products is equal to count by products comma costly product predicate. Now we can say total number of costly products. Costly products is equal to, save this, so this will be number of costly products. Now go back, reload this, there you go, right? It says total number of costly products are 4. There are 4 costly products. So like this, you can count by a particular, predicate, right? You can count by a particular predicate. Okay, good. Now let us look at some of the aggregation functions, right? How we will implement the aggregate functions. So display, what is aggregate function that we want to implement? Min, right? A function. Okay, very good. Now how do we do min? Very simple. The user has to tell me on what basis he wants to find out the minimum, whether he wants to find the minimum of cost or units or whatever, right? So whatever attribute by which he wants to find it minimum, he need to let us know. So we will write the function. So function min, take the list and a value selector, right? Think of it as a value selector. So what I will do, or the min function will do, is where result equal to value selector of list of 0. It will pass the first item, right? First item to the value selector and get the value. So that will become the reference point. And then for where I equal to 1, I less than list dot length I plus plus, we will take one value at a time. So where value is equal to value selector of list of I, take one value at a time. If result is greater than the value, then result equal to value. Then result equal to value. Finally, we will say return the results. Right? Return the result. Now, let us use this to find out the minimum of the cost. So, where cost value selector is equal to a function that takes one product and returns the product dot cost, just the product dot cost, that's all. Now where min cost is equal to minimum of products comma cost value selector, right? Cost value selector, and say console dot log minimum cost is equal to comma min cost. Save this, go back here, reload this. What is the minimum cost? 30. Is it so? Let us look at this. 40, 70, 80, 60, 30 and 90. Yes, we are right. Right, the minimum cost is actually 30. Right now, so what I will do, I will do the iteration, I will do the comparison, but you need to tell me for each object on what value, on what basis you want me to perform the minimum, right? So that I am delegating it as a selector function, and let the user pass that particular function. I will perform the minimum and then return it. Right? Now you can do the same thing with max as well. Max is not very complex, so we'll simply say this will be max and this is max, and what I will do, if result is less than the value, do this. Now here we will say max of products comma cost value selector. Now this will be max cost, maximum cost. Save this, go back, reload this. You see what is the maximum cost? 90, right? The maximum cost is 90. Like this, you can find the maximum of anything and everything, right? You can find the maximum of units. So where max units is equal to max of products, I'm going to inline the value selector. So a function that takes a product, return p dot units. Return p dot units. Now similarly, we'll do a console.log maximum units is equal to comma max units. Right? Now let us see if that works. Reload it. You see the maximum units is 80. Let us look at the units. So units is 60, 30, 80, 50, 70 and 20. So obviously 20 is the maximum. Right? We are able to get that. So min, max, sum I think you can automatically write. So I am going to leave a sum to your homework. Okay. Aggregate. Aggregate is where the user should be able to aggregate the list. Right. Minimum is one form of aggregation. Maximum is another form of aggregation. Count by is another form of aggregation. And sum is another form of aggregation. Right. Like that, the user should be able to write his own aggregation logic. Right. Whether it is average or sum or whatever it is, he should be able to aggregate it by his own logic. So how do you do that? Basically what I will do, you remember we wrote the during the first, I think second day, we wrote this sum of 10 comma 20 comma 30 comma 40 can be written as sum of 10 plus sum of 20 comma 30 comma 40, right? You remember we wrote this, right? Now you are going to write a generic function, the generic function that is going to let the user do this. Guys, are you there? Yeah, right? Okay, good. Thanks. Okay. So now we are going to write a very generic function that does this. How? Let me take you through that. Display aggregate a function. What I will do is function aggregate takes a list, okay, takes a list and an aggregator function comma a seed value. Okay, so the seed value is the initial starting point, right? What is a initial starting point? Now what I will do, I will say where initial result is equal to aggregator of, first pass the seed value, so seed comma list of 0, the first one, okay, and then for where I equal to 1, I less than list dot length I plus plus, simply do this, result is equal to aggregator of result comma list of I, and finally return the result. You are done. That's it. So this will take care of doing it. For example, I want to sum all the units, right? I want to sum all the units. So we'll say where sum of units is equal to aggregate the products comma a function that takes a result and a product and returns the result plus products dot units, right? Returns result plus products of units. Now this is what I will be returning, comma, what will be the seed result? The seed is 0. Now watch this. We'll say console.log sum of units using aggregate, right? Okay, sum of units is equal to comma sum of units. Now save this, go back, reload this. You see, oops, sorry. Products of I dot units. Sorry, products of I dot units. Now reload this. I is not defined. Where is I? Oh, sorry. Product dot units. What am I doing? Product dot units. You see, it says 310. We have added all the units. Look at this. 6 plus 3 9, 9 plus 8 17, 17 plus 5 22, 22 plus 9. I'm sorry, 22 plus 7 29, 29 plus 2 31. And have we got the result 31? Right? Now, similarly, you can calculate the minimum of units. What did we do earlier? The maximum of units, right? So we will also calculate the maximum of units using aggregate. How? Watch this. Where max of units is equal to aggregate of products comma a function that takes a result and one product, and we will simply maximum, right? Return if result is greater than product dot units, then return the result, otherwise product dot units, right? Otherwise return product dot units, and then comma, what is the seed result? I'll say seed is 0. Now you say console.log max of units is equal to max of units. Save this, go back, reload this. You see, here also we got it, here also we got it, except that here we are using a generic aggregate function to do that, whereas here we used a very specific max function to do that. The beauty of the aggregate function is you can apply your own logic. You can apply your own logic to check whether the your own logic of aggregation, right? For example, let us look at this. In the case of max, okay, we found only max units, but I want to know which is the product that is maximum stocked. I want to know the product. I want to know the product that is stocked to the maximum, right? So where max stocked product is equal to aggregate of first the products comma a function, you take the results and one product at a time, and comma the seed value is 0, and in this function I will say return if result is greater than product dot units, then okay, so we will also have to do something else as well. We'll also have to do something else, which is if the seed value is not there, use the first one, right? If the seed value is not there, use the first one. So one second. If seed is there, then take the seed. Otherwise, take the first one. So how do you go about doing that? So if not seed, if seed is not there, then seed is equal to list of 0, and first where first is equal to list of 1, where first is equal to list of 1, and where start is equal to 2. We have to start from the second one. Else okay, so these two are first. So I'm writing some really junk logic here. Let us fix this. So this is your first and this is your start. Start is equal to 2. You have to start from 2. Otherwise, if not seed, if seed is present, then first is equal to list of 1, list of 0, and start is equal to 1. Start is equal to 1. So here this is I equal to start, and this will be seed comma first. Seed comma first. Very good. Now this should do, right? You don't need to give any seed. You don't need to give any seed value. Now you can check if result.units is greater than product.units, then return results. Otherwise, return the product. Now console.table of max stock product. Console.table max stock product. Let us see if we are getting a product with the units 80. Console.table. You see here, what did I do? Get the console. Okay, this is only one product, right? This is only one product, right? So it is now here you go. You see, right? So max stock product is equal to comma this. Save this. Go back. Reload this. You see, max stock product is equal to an object. What is the units? Units is 30. Right? So we are able to aggregate it based on the products. Okay. Now this is about aggregate. You can write your own aggregation logic, whatever you want, right? You can write. Group by. Group by is a lot more interesting. So basically, what I want to do, I want the user to be able to group the items by something, right? What is that something? That something is the user will decide what that something is, right? So let us write that. Display group by comma the function, and here guys, am I audible? Okay, sorry, because I got a message saying that my audio quality can be poor. Okay, right? So group by, let us write a simple group by function. So function group by, what is that I want to group by? Obviously, I want a list and a key selector, because the user is going to tell me what is a key based on which he wants to group the products, right? What is a key based on which he wants to group the products? Now I need a key value pair to maintain the group of items, right? I need a key value pair to maintain a group of items. So what can be a key value pair, key value collection in JavaScript? What is a dictionary in JavaScript? What if I want to have a dictionary in JavaScript? What is a dictionary in JavaScript? object, guys. Object is the dictionary, right? An object is nothing but no. And a plain simple object is a dictionary, isn't it? Yeah, right. So anytime you want anytime you want a dictionary in JavaScript, use a simple object, right? So here, let me do this. Watch this. So where result is equal to an empty object, and then for where I equal to 0, I less than list dot length I plus plus. Take one item at a time. So where item is equal to list of I, and get the key where key is equal to key selector of item. Get the key for that particular item. Check if the key already exists in the result. So if type of key is equal to undefined, it is not there, then what do you want me to do? Not type of key. If type of result of key, right? If type of result of key is undefined, then I want to initialize it with an empty array. So result of key is equal to an empty array. Now that you have initialized it, we will simply say result of key dot push this particular item and return the result. That's all. We are done. This is what all it takes, right? So now let us see. I will say where products grouped by category is equal to a function. Group by products, comma, I need to pass a key selector. So a function that takes one product at a time and returns the product dot category. Returns the product dot category. Okay. Now let me do a console.log of products grouped by category. I'm just simply doing a console.log of products grouped by category. You see, this is nothing but an object. The object contains two attributes. What are they? 1 and 2. What is 1? 1 is category 1, 2 is category 2, and 1 contains all the products that belong to category 1. You see, this is category 1, this is category 1, and this is category 1. And 2 contains the array containing all the products that belong to category 2. See how neatly your products are grouped, 1 and 2. Right? How neatly your products are grouped. So this I will say products grouped by category. Okay. Now similarly, let us write a group by of cost. So where products grouped by cost is equal to group by of products, comma, the function that takes one product at a time and does something. What is it? It checks the cost. So return if the product.cost is greater than 50, then it returns costly. Otherwise, it returns affordable. Earlier, the attribute of the product, one of the attribute values acted like a key. Right? The products, one of the attribute values acted like a key. Now, you are creating your own key based on a logic. You are creating your own key based on a logic. Now look at this. I will say console.log products grouped by cost. And what is this? This will be products grouped by cost. Now save this, go back, reload this. Now you see this is products grouped by cost containing an object, and the object contains two attributes. One is costly, the other one is affordable. One is costly, the other one is affordable. So no price for guessing. So I'll say console.table of console.log costly. Right? Console.log costly, and we will say console.table what is it? Products grouped by cost of costly. Whatever is the key that you gave here, right? You can use that to locate it. Now similarly, we'll also take affordable and this will be affordable, right? Save this, go back, reload this. You see, we got these are all the ones. So these 4 items are there in this particular array, and these 4 items are there in this particular array, right? So we wrote one group by function that can be used to group the products by any particular key value, and you have the flexibility to decide as a user. You have the flexibility to decide on what basis you want the products to be grouped. On what basis you want the products to be grouped. Guys, do you understand? Right? So we almost wrote all these implementations ourselves. We almost wrote all these implementations ourselves. Now, take a few minutes, go through it, and let me know if you understand. Code is checked in. I'll give you 10 minutes. So you have, it is 9:50. So go through it till 10 and let me know if you have any questions. I'll touch base with you at 10 o'clock. Any questions? Any questions? Okay, now here is the thing. Here is the thing. You don't have to write any of these functions. You don't have to write any of these functions. All these functions, whatever we wrote, sorting, filtering, any, all, min, max, sum, average, count by, group by, right? All these functions are available as a library, right? All these functions are available as a library, and the library is Underscorejs. Okay, and the library is Underscorejs. Now it is a nice simple library. The Underscorejs is a collection of functions, collection of utilities, right? It is a collection of utility functions which you can use in your applications. Now you see here, you find reduce. Reduce is what we wrote as aggregate. Reduce is what we wrote as aggregate. You see, reduce takes a list, takes an iterative, and takes a memo. Memo is what we said as the seed, right? Memo is what we said as the seed. So the reduce is our aggregate. Filter is what we wrote. You see, list and a predicate. Filter, and every is what we wrote as all, and sum is exactly what we wrote as any, right? You pass a predicate function and it is any, sum is any, and then you see we have min, we have max, right? And sort by, right? List, iterative. The iterative is basically your comparer, the comparer, and sort by. You also have group by. So the group by, list, and iterative. The iterative will return the key by which you can group those items, right? You say group by an array of 1, 2, 3, and how you want to get it? I want to get it by the length. Here 1.3, 2.1, 2.4, function num, return math.floor of num, right? So basically what you are doing, you are grouping it by the math.flow. So 1.3 will return 1, and 2.1 and 2.4 will return 2. So now these are grouped by 1 and 2. It's exactly what we wrote, except that, right? It is ditto what we wrote. Right? What we did is, instead of learning how to use these functions, we learned how to create these functions, right? We didn't learn how to use them. We learned how to create them. Why? Because once you know how to create them, it is very easy for you to use them. It doesn't make much effort for you to use them, right? Say for example, look at this, right? So look at this. It says index by. So basically what you do, you create an index. You have an array of objects and you want to create a group by, not exactly a group by, an index by one particular attribute. So here there are 3 different objects, name and age. Name Larry, age 50. Name Curly, age 60. And you want them to be indexed by age. Now when you apply that, you see what you get. You get an object. The age becomes the attribute and the object becomes the value. So this is kind of group by, except that in group by you collect them together in an array. Here you convert each of the attribute value into an index, right? See, just like group by, but for when you know your keys are unique, but for when you know when your keys are unique, right? So these are all the functions that what you should do is, you should try to create these functions of your own, right? You should try to create these functions on your own. For example, I will show you. Okay, so let us just take index by. Let us just write index by. So if I have to write index by, how will I write? So display of index by, comma, a function index by, take a list, comma, iterative, take a list, comma. Okay, this is an attribute name, right? What you get is an attribute name or an iterative, whatever, it doesn't matter. Okay, so I'll say iterative, and here where result is equal to an object, and for where I equal to 0, I less than list dot length I plus plus results. Let us do this. Okay, so now where key is equal to a list of I of iterative, and then result of key is equal to list of I. That's all. That's all. Now return the result. Return the result. Now console.log, what is your result? Console.log, what is your result? Let us do this. We have this data, isn't it? Where Stooges equal to this. So let me take a copy of this data, drop it here, and then I'll say where result is equal to index by Stooges, comma, what is it? By age. Whatever you do here, you are doing the same thing. Now look at the console.log result. Go back here, reload this. You see, you have 40 an object, 50 an object, 60 an object. Now what does 40 contain? 40 object contains 40 more. 50 object contains 50 Larry. 60 object contains 60 Curly. So this is exactly what is the result that you got. So you got an object that contains 40, 50, 60. 40 has an object Mo, and 50 has an object Larry, and 60 has an object Curly. Right? That's it. As simple as that. So you wrote your own implementation of index by in a matter of just 6 to 7 lines of code. Right? In a matter of just 6 to 7 lines of code. So in fact, what you can do, you can simplify, you can reduce the number of lines of code. You know, if you want to compromise on the readability, you can reduce the number of lines of code drastically. You can reduce the number of lines of code drastically. That's all. This will take care of it. Right? So like this, what you should be able to do is you should write your own implementation for all these functions. Try to write your own implementations for all these functions. This can be an excellent exercise if you want to gain confidence in JavaScript. Right? This is one very easy and very important exercise that you can do. Take one function at a time. Understand what the function does. You take invoke, for example. Right? Take invoke, for example. Calls the method named by method name on each value in the list. Any extra arguments passed to invoke will be forwarded on the method invocation. Try to write your own implementation for this. Pluck. Try to write your own implementation. Understand what the function does, and you try to write your own implementation. And see, you also have the samples here. So take the sample and call your function and see if you are getting the appropriate result. Okay, so like this, you should try to write your own functions, and these functions vary in different purposes. So these are all collection manipulation functions. These are all array related functions. These are all function related functions. These are all function related functions. You remember we wrote a function called negate inside the filter, right? In filter, we wrote our own function called negate. Right? We wrote our own function called negate. You see here, this library has a function by name negate. You see, negate. So what does it do? It takes a predicate. That's all. Whatever we wrote returns a new negated version of the predicate function. That's exactly what we wrote. Returns a new negated version of a predicate function. Right? So whatever this function is expected to do, we wrote it ourselves. Right? Whatever this function it does in the library, we wrote it ourselves. Like this, you should be able to write your own implementation. You should be able to write your own implementations. Okay. Now let us write one more implementation. You see here, Memoize. Huh? Now this is something that we did already. You see, Memoize a function and a hash function. So what is a hash function? The hash function is used to generate the key. For example, if you take our prime finder that we wrote yesterday, not yesterday, day before yesterday, closures, right? Where is our? Did we write a prime finder function? Do you remember us writing a prime finder? Memoization, yes, there it is. Guys, are you there? Okay, do you find the class going very boring? Are you following? I am not able to get any idea about how you find the class is going.
It's fine actually, like the way that you just told about the Underscorejs, it's excellent actually, but like it's almost like 1 a.m. for us, so we are like closely monitoring the things, but like we are not able to think actually.
Okay, no issues, no issues. But you are following, right?
Yes.
Good. Okay, right? So now the memoize. So whatever you have here as memoize, whatever we have here as memoize is a generic version of what we wrote. A very generic version of what we wrote. If you recollect what we did in the get prime finder function, right? So what we did, we wrote a function that remembers the previous results, right? We wrote a function that remembers the previous results. Now think of it like this. Let us check. Let us assume that I want to write even number finder function. I want to write a even finder function. So for example, function is even. Take a number and you say return if number mod 2 is equal to 0. Okay, very good. But I want to cache the results of this. So console.log processing for comma number, right? Processing for number. Okay, very good. We have written this. Now, but the way I was able to remember the results of is prime function, I also want to remember the results of is even. So what I have to do, I almost have to repeat the same stuff once again. So I'll copy this, paste it here, name the function as get even finder, and the only thing that I have to do is replace the is prime function with the is even function, and instead of calling is prime I have to call is even. Instead of calling is prime I have to call is even. Now, right? So let us see if this works. Copy this, go to the browser, paste it. Now where even finder is equal to get even finder, and then call even finder of 100, processing for 100. Call it again, there is no processing for 100. 101, processing for 101. Call it again, there is no processing for 101. Now call even finder of 100. You still don't get processing for 100, right? Because it remembered it from the cache and it is returning it. So now if you look at it, between these two implementations, right? What changes is only this function. Instead of this function, you used this function. But other than that, everything remains the same, right? Now, is there a way by which I can make this generalized? Of course you can. How? Very simple. What I will do, let's look at the memoize. What the memoize does. Let's look at memoize, right? Memoize takes a function. So similarly, what I will do, let me write the memoize. Memoize, whatever you are internally writing it, pass it as an argument. Pass it as an argument, and you say, okay, here you say fn of n. Fn of n. That's all. Now you have returned a generic version of the event finder. Now how can I use it? I'll show you. Watch this. Now where event finder is equal to memoize of one function that takes a number and that returns. Okay, so we'll also do a console.log. So console.log processing for comma n, and then return n mod 2 is equal to 0. N mod 2 equal to 0. Now you call event finder of 100. It says processing for 100 true. Event finder of 101 processing for 101 false. Now call for 100, there is no processing for. Call for 101, there is no processing for. Right? So with the memoize, you can memorize any function's result. Any function's result. Now let us look at prime finder. Let us take this. We have this function as prime finder, right? So copy this. Let's go back here where prime finder is equal to memoize of whatever function that we wrote. I am just simply passing it. Now let us say prime finder of 100 processing for 100 false. Prime finder of 101 processing for 100 true. 101 is a prime number. I don't know that. Okay. So 107 processing for 107. It is also true. 109 processing for 109. It is also true. Now you call 100. It says false. There is no processing for 101. No processing for 107. No processing for 109. No processing for. So, but what I wrote, all I wrote is one logic for checking whether one particular number is a prime number or not. The memorize function returns a function that knows how to memorize the results of this function and return it from that particular result. And how difficult was it? Very simple, right? Just 6 lines of code, 7 lines of code is what all it took to write the memoize implementation. But you will find that there is one more problem. What is the problem? It also has a hash function. It also has a hash function. So what is the problem with hash function? Why do I need a hash function? If the function that you are passing takes only one value, then I can use that as a key. But what if the function takes more than one arguments? For example, what if I say where memoize of the function that takes x and y and says console.log processing for comma x comma and comma y, processing for x and y, and we will also print the result, return x plus y, return x plus y. Okay, I'm sorry, there is some problem. So memoize console.log return x plus y, that's your function. Yeah, I think we are good now. Okay, so where add fn equal to memoize is not defined, sorry, I think I reloaded the page. Okay, memoize and then add fn, come on, oh sorry, spelling mistake, it is yeah, I saw that memoize, right? Now you call add function of 10 comma 20. It says processing for 10 and undefined, y, x and y, processing for x and y. Why is y undefined? You see why? The reason is your memoize function returns a function that takes only one argument. So when you called the add fn of 10 comma 20, only 10 was taken into consideration, 20 was never taken into consideration, right? Because what your memoize function is returned to handle a function that takes only one argument. What if I want to take multiple arguments? What if I want to take multiple arguments? Very simple. What I will do, I will use the arguments. I will use the arguments, exactly, right? So fn dot apply of this comma arguments. Okay, when I passed only one argument, I used that as a key. But if there are multiple arguments, what will I use as a key? What will I use as a key, right? So that is where your hash function comes into picture. So hash function, and here you can say, right, And what you will do, you will say this is not the key, where key is equal to hash function dot apply of this comma arguments, and then this will be your key, and here you will say cache of key, and this is return cache of key. Now this is an implementation that you can use across different types of arguments. Like say for example, let us write the same add function. So add function memoize, this is one argument that I am passing. So this is this is one function argument that I am passing. So this is your actual add function. Okay. Now on top of this, I also need one more function. I need to pass one more function that will give the hash. So this will be the hash function, where I will simply say return window.json dot stringify of the arguments. I am creating a string version of the arguments, and I want that to be used as the key. Now look at this add fn of 10, 20. It says processing for 10 and 20, 30. Now 100, 200. It will say processing for 100 and 200 and 300. But now you call 10 and 20, there is no processing for. 100 and 200, there is no processing for. Right? The add function, the memoize can, now this version of the memoize can do memorization of any function taking any number of arguments. Any function taking any number of arguments. So this is exactly what is here. If you look at here, this is exactly what is here. If you look at the memoizes a given function by caching the computed result, useful for speeding up slow running computations. If passed an optional hash function, it will be used to compute the hash key for the stored result based on the arguments to the original function. Right? Based on the arguments to the original function. Right? So try these things. Now you should try to write these functions of your own. Now look at this. What is it? Let us take one more. After creates a version of the function that will only be run after first being called count times. Right? First being called count times. So basically what this does is, if I say after of 3 comma function, this will return a function, and your original function will be invoked only after you invoke it 3 times. So if I have to write my own implementation of after, right, it will go something like this. Function after, take the count and the original function, and all I will do is where count is equal to times, right, where count equal to 0, and return a function, and every time you call this, increment it. If plus count is greater than or equal to times, then you call the original function, apply this comma arguments. That's all. This is what is all about after. Now let me show you. Now done this. Now we'll say where fn equal to after 3 comma function console.log, this will be executed only after 3 initial invocations. That's all. Done. Now you invoke this function first time, nothing happened. Call it again, nothing happened. Call it again. Now you see this will be executed only after 3 initial invocations. It has happened the 3rd time, but you can write the simple logic only if it is greater than. Right? Only if it is greater than. That's a logic mistake here. So now you say, now invoke fn. It says first time nothing happens, second time nothing happens, 3rd time nothing happens, the 4th time it says this will be executed only after 3 initial invocations. So you see 3 times you executed, nothing happened. Now that is about after, the same thing what after does. Similarly you have a before, right? Creates a version of the function that can be called no more than the count times. right? Create a version of the function that can be called no more than the count times, right? So now this is more or less the same after, but does a slightly different job. Like this, you have a wrapper, you have negate, you have compose. Now you have all these functions. Try to recreate these functions of your own, right? Try to recreate these functions of your own. Okay, so this will be an excellent exercise for you to gain confidence in the language. Make sense? So what we discussed is not how to use underscore, but how to create underscore, how to create a library like underscore, right? So give it a shot, try it, and you will thoroughly enjoy the process. Right? Any questions?
Okay. Okay. It means like most of these libraries that they developed are like the same way they implemented, right? Like either it's underscore or like any other things.
Correct.
Okay.
Right. Good. Now let's stop with this, and I'll check in the code, and as usual, I will upload the video tomorrow morning, and you can take it for reference. Go through it when time permits, and as I said, don't forget. Try to recreate these functions of your own that can give you a lot of comfort. Right.
Is there any book or something that you can suggest for, because we saw many books are like online tutorial in Google, but like we didn't I never went this much detail actually like in any of the books. So is there any book that you can recommend, Magesh?
That's the value addition that I am bringing to the table, sir.
Okay. Okay.
Okay, so there is one book called Functional Programming in JavaScript. Not many would have gone through it, but there is a book called Functional Programming in JavaScript. Especially whatever we discussed yesterday and today, it will be covered. It is covered there.
Okay.
It is a Rocks publication, very old book. I haven't seen the book for a very long time. It's called Functional Programming in JavaScript.
Okay. Yeah, thanks, Magesh. Thank you.
No. Rupa, we are done. Right then, I hope these discussions are useful, and we'll catch up tomorrow then with a little more simple, nice, complex discussion. Right? Thank you. We'll meet tomorrow.
Okay. Thank you. Bye. Okay. Bye.